After that, we'll explain the ionization energy. Another property is the ionization energy or ionization enthalpy. The minimum amount of energy, the minimum amount of energy required to lose the electrons from the neutral gaseous element is called ionization energy. So minimum energy we need to eject the electrons from the outermost neutral gaseous element. So its unit is kilojoule per mole or electron volt per atom, right? It is a successive process. That is why one atom can lose one or more than one electron, but one after another. So it is a successive process. That is why ionization energy 1 is smaller than ionization energy 2 is smaller than ionization energy 3rd. Because of it is easy to lose one electron. Again you provide the double energy to lose 2 electrons, and you provide the triple energy, 3 times more energy to lose the 3 electrons. That is why sodium 1 positive needs less ionization energy. Then what is that? Magnesium 2 positive, and then you can say aluminum 3 positive. It needs less you can see ionization energy than magnesium and then aluminum. That is why if any element solid state, first you let it convert into the gaseous state. That state is known as, whenever any solid substance directly converted to the gaseous state, then it is called as sublimation. Now it will lose 1 electron, so it is called as ionization energy 1, and then magnesium M, that M is a kind of metal, require 1 unit positive charge. So once you provide the energy to eject the electron, so ionization energy is a what process? This is the endothermic process. Because of you provide the energy to the system, and electrons are lost and they become stable inert gases. For example, if I say sodium in the solid state goes sublimation, sodium in the gaseous state minus 1 electron, sodium positive, delta H, which is the positive, because of it is what reaction? It is the endothermic reaction. But ionization energy does not have the fixed trend. Actually, in general, we can say that ionization energy also depends upon the size of the atom. So, factors affecting ionization energy, right? Ionization energy is inversely proportional to the size. First of all, greater the size, lesser the ionization energy. It's simple. If I say lithium, sodium, potassium, rubidium, cesium and francium. So, lithium has more ionization energy than sodium, potassium, cesium and francium. Francium is a radioactive element, otherwise cesium is considered as the most electropositive element. Because of, otherwise francium should be considered as the most electropositive. But dear students, francium is a radioactive element, unable to form the compound. But Cesium getting the positive charge and easily lose the electron because of it has 6th number of periods, 6 cells. Therefore, it is difficult to lose the electron from the lithium ion than the cesium and francium ion. That is why cesium can form very strong ionic compound as compared to the lithium. So down the group, if I say beryllium, magnesium, calcium, strontium, barium and radium. 2 positive, 2 electrons in the last orbit. So beryllium, magnesium like this. So the ionization energy going to decrease, right? Because size going to increase. But along the period, full filled is more stable than half filled than what filled? Incomplete filled. We have to take care of group 2nd, group 15 and group what? 18, that is the inert gas. If I say period 2nd, like lithium and then beryllium, then you can say carbon and then nitrogen, then you can say oxygen and fluorine, and the last is what is that? Neon. So here group 2nd, group 15 and group 18. Right, this is the group 1st period, this is the 4th, 14 and then 16, 17 and 18. So that is what it is, the inert gases. One thing, lithium, beryllium and other is the boron and then carbon. 6, 7, 8, 9, 8, 9 and 10. No doubt, lithium has greater size. So obviously lithium has the lowest ionization energy, but beryllium is a fully filled condition. That is why even the size of beryllium is greater, but ionization energy should be also higher actually as compared to the boron, because of once you write the electronic configuration of the beryllium, you write 1s2, 2s2 like this. So once you write the configuration of the students beryllium, then you write 1s2 and 2s2. This is what filled, fully filled. So it needs more ionization energy. That is why here boron will come and then beryllium. Second is the group 15. You can say nitrogen 7, 1s2, 2s2 and 2p3. P3 means half shells, half filled orbital, 1, 2 and 3. It is more stable than the incomplete filled. That is why you have to be very careful in answering the question. No doubt, lithium has maximum ionization energy than boron, and then you write beryllium. Right? Beryllium has more ionization energy than boron, and then carbon, and then you write oxygen, then you write nitrogen. Why I have changed like this? Because nitrogen is the half filled electronic configuration and beryllium is the fully filled. And no doubt, fluorine is alright and neon is alright. So here it is the actual case, right? Just like you apply this system in period 3rd of the periodic table, like this. 3rd period, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and what is that? Argon. So in period 3rd, expected order of ionization energy. Sodium is lesser than, say, okay, one thing dear students here, lithium has lesser than boron, then beryllium, carbon, nitrogen, oxygen and all right. Now sodium has lesser ionization energy than magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and what is that? Argon. But you remember it is the fully filled condition, right? And phosphorus is the half filled condition. It is the member of group 15, it is the member of group 18, and argon is the member of group 18. So you have to be very careful. Actual order is like this. No doubt sodium has the lowest ionization energy because of the greater size in its respective periods. But you change here aluminum and then magnesium, silicon, then you write sulfur, then you write phosphorus, chlorine, and it is the argon. So expected order is different from the actual order. So the trend is bit changing from LHS to RHS. But down the group, no confusion. Everything is very much clear. Down the group, atomic size going to increase, number of cells going to increase, and energy of ionization going to decrease. Am I clear to you? Okay. Then another factor is that the penetration effects. Penetration effects. S is very close to the nucleus, then P, then D, and then F. It is a nucleus, so S has maximum penetration, then P, then D, and then F. So it is difficult to lose the electron from the S, then the P. For example, if I say aluminium, right, 13 atomic number, it is the neon, so 3s2 and 3p1. Which has more penetration? S has more penetration, means attraction of the subcell with the nucleus, because S is close to the nucleus rather than the P. Therefore, these electron and these two electrons are repelled to each other, a sort of ding dong. As such, this one electron is easily lost than the two electron. So aluminum can provide +1 and +3 oxidation state. It is the minimum, and this is what is that? Maximum oxidation state. This phenomena is known as inert pair effect. What is inert pair effect? The reluctance unwillingly, the reluctance of NS2 electrons to take part in chemical reaction or bonding is called inert pair effect. S subcell is not reluctantly to participate in the bonding. Actually, it is the unique property of the P block, because S and P are the outermost shell. P can lose the electron easily as compared to the two. That is why it will show first the lower oxidation state, and then 2 + 1 maximum is shown by the aluminum. Similarly, in case of aluminum and then gallium, then indium, and then thallium, it will show +1, +3, +1, and +3. This phenomena is known as inert pair effect. I give you the example of group 14. Like, see, so far as group 14 is concerned, carbon, silicon, germanium, tin, and lead. So carbon shows anomalous behavior because of the smaller atomic size and high ionization energy. Therefore, it will not show inert pair effect. But so far as silicon is concerned, all this configuration is like this: NS2 and P2. First two electron will be lost, and 2 + 2, 4. Every element has same kind of status: +2 and +4, +2 and +4. It is all due to inert pair effect. As such, the atom with lower oxidation state can form a compound which is ionic and solid, and the atom with higher oxidation state can form a compound which is covalent and liquid. This phenomena is called as inert pair effect. If you are put to a question like this, SnCl2 is ionic and solid, but SnCl4 is covalent and liquid. Why? Because tin will show +2 as well as +4. If it will show SnCl2 or SN2Cl. Similarly, SnCl4 can be written SN4Cl4. 2 electrons is lost very easily and 4 electrons lost very difficultly, in a difficult form. Therefore, SnCl2 obviously ionic. Because of conditions for ionic compound, you will study in chemical bonding that should have low ionization energy. That is why it is the conditions for the ionic compound. It is all due to what effect? Inert pair. It is the sufficient answer. Similarly here, PbCl2 is PbCl2 is ionic and solid, while PbCl4 is covalent and liquid. Why? Similarly, Pb, lead, plumbous chloride and plumbic chloride. Initial case was stannous chloride and stannic chloride. Same answer. It is all because of inert pair effect. What is that? Now we can go for, you can see group 16, oxygen, sulfur, selenium, tellurium and polonium. Polonium is a radioactive element and oxygen has anomalous behavior. Anomalous means the unique behavior due to a smaller atomic size, high ionization energy and absence of vacant d orbital. Therefore, members of the second period of the periodic table show anomalous behavior, unique behavior. That is why it will not show the inert pair effect. But so far as sulfur is concerned, selenium and tellurium, its configuration is NS2 NP4. First 4 will be lost, +4, and then 4 + 2 6. One is the lower, another is the higher. This phenomena is known as inert pair effect. Now +4 and +6, +4 and +6, like this. So far as group 17 is concerned, like fluorine, chlorine, bromine and iodine. So it will not show inert pair effect, but configuration is NS2 NP5. 5 will be lost, +5 and +7, +5 and +7, +5 and +7. This is the unique property of p block elements. Usually they exhibit lower and higher oxidation state. This credit goes to the inert pair effect. So obviously ionization energy depends upon symmetry, stability, size going to increase, ionization energy going to decrease, but exactly half filled, fully filled and inert gases have very high ionization energy irrespective of their greater size. And then penetration effect, and last is the shielding effect. Last part which can influence the ionization energy or enthalpy is the shielding effect, or you can say a screening effect. More the screening effect, lesser the ionization energy. I mean the outermost shell and the intervening electron. If I say lithium, sodium, potassium, rubidium, cesium and francium, 3, 11, 19, 37, 55 and 87. Dear students, it is the nucleus, positive charge, and then configuration is 2 and 1. Nucleus 2, 8 and 1. Nucleus 2, 8, 8, 1. In case of 2, 8, 18, 8, 1. Nucleus 2, 8, 18, 18, 8, 1. Nucleus 2, 8, 18, 32, 18, 8 and 1. So try to understand, it is the outermost orbit where it is very easy to lose the electron gradually, because down the group atomic size increases. Therefore, the attraction between electron, valence electron and the nucleus going to decrease. So that electron is being shielded, protected by the nucleus, because of the distance of the last electron from the nucleus is quite large. Therefore, more the screening effect, more the shielding effect, lesser the ionization energy, and it's vice versa. Where whatever the electrons present except the valence electron, and these are called as core electrons. This is known as intervening electron. Intervening electrons. Therefore, these electrons going to protect the electron from the outermost orbit, from the nucleus. That is why it is a screening effect or shielding effect. The repulsion between intervening electron and the valence electron. Down the group, atomic size obviously going to increase, intervening electron repulsion also going to increase, ionization energy going to decrease. That is why it is known as shielding effect or screening effect.